Let me just go over the last slide. I was just about at this point, I think. So we're all up and running again, I hope. We had just talked about, hopefully, this is the slide that I was on, talking about the actual process of the charrette. Maybe I'll just kind of roughly go over that again, looking at the graph to the left. The first part of the session is with the help of a facilitator, topics are discussed after they are agreed to by the entire workshop. Second, small groups are formed, typically 4 to 5 people per group, and you want a diversity of people in those groups. Third, groups are assigned a topic to start the process. Topics are then brainstormed for approximately 15 to 20 minutes per topic. Each group will have someone that's willing to take good notes and be available to pass that information on to the next group. This allows each group to build on each other's discussions. So there's a feedback loop happening. New topics are then introduced and the process continues until all groups have brainstormed and recorded each potential topic. Notes from all the groups are then assembled. The entire group comes back together for open discussion, feedback, and then prioritizing and finding consensus on action items moving forward.
Anthony, I have to interrupt. I don't think you're sharing your screen anymore.
Oh man. Okay. Let's see. Okay, how's that?
Great.
Okay, so anyway, getting to the payoff basically and the benefits of this workshop idea. What you end up with is stakeholder buy-in first. That's, for me, that is the most important part of the process. If you can get stakeholder buy-in and responsibility, you really see the rest of these benefits kind of fall out of that and build around that success. So what you end up with is shorter build timelines, of course, lower construction costs and savings there, the massive savings and lower construction costs and lower operational costs. You're essentially building on what your biggest goal is, hopefully, and to meet that triple bottom line and become a profitable, sustainable company moving forward. And again, this process can be done for 10,000 square foot builds or 200,000. Of course, you have to find the structure that works for you. And but I think if you really run it and you stick to the format that you present, you're really going to find huge benefits moving forward. So with that, Jeremy, I think I'm going to go ahead and pass it over to you, and I'll stop sharing at this point.
All right, thank you. Okay, if I can get, it says the host has disabled participant screen sharing. If someone could turn mine on. I don't know if you're still there. Anthony, you might have to drive this. Apologize for the delay. All right, guys, bear with me. I'm trying to get my permission to share my screen here. All right, here we go. All right, can you guys see my screen? All right, great. Okay, Anthony, thank you for the introduction. I'm Jeremy Hatfield with Alpha MEP. I'm an engineer with 20 plus years of experience doing mechanical, electrical, plumbing, engineering. With respect to the Charette, it's true most of the time you see it in the architecture, land planning arena. I'm fortunate to have some good experience with a military background. A lot of the more complex military projects have a mandatory sustainability charrette when you start the project. So feel very fortunate in that regard. So first thing, I'm going to go through some examples. First thing I want you to understand, this is not a design guide. This is an example of why the Charette process is important. Oftentimes, MEP, mechanical, electrical, plumbing engineers are involved very late in the process, 20, 30%, that's too late for a complex project. If you're doing like a strip mall, sure. But for something like cannabis, very important to get us involved very early. And that helps make those decisions complement each other rather than to lead to just complications and wasted cost and wasted time throughout the construction process and even after the construction process. So very important, get organized, identify your team, your responsibilities, identify the goals and priorities of your team, create a schedule, and in that schedule, make sure you're putting critical path items in so the project can progress. This is a bunch of topics, and I pulled this off a questionnaire that I typically send out to everyone when I start a cannabis project. Everyone being if it's design build, will be involved, the contractors, architects, the owner, the growers, anyone that has good input on the process. And you'll notice in this list, not everything on here is, directly related to energy. And you're right, sustainability is not just about energy savings, it's about keeping your system, your system sustainable. So keeping it maintained so it operates at the most efficient level that it can for as long as it can. Bear with me a second here. So another example on this list that is often overlooked and very important in cannabis is system redundancy. If you're designing a commercial office and your air handler goes down, people can go home. The plants can't go home, so they're stuck there. If the power's lost, cooling's lost, heating's lost for an extended period of time, you can possibly kill your plants, or at best case scenario, do damage to the yield. And on this list, well, one thing I want to point out, and I'm going to touch on more in the next slide, is all these topics interact with each other. And you can't design in a silo, as Anthony pointed out. So this first example, starting with lighting, I'm going to have a slide where we're comparing high pressure sodium versus LED, and that's going to have an impact on so many things. So it's going to affect your lighting control strategy, which is going to affect your first cost. It's going to affect your HVAC system, which can lead to different equipment capacities, mechanical room sizes, which then in turn affect these other things like energy cost and first cost and your power service size. So this decision needs to be made in conjunction at the beginning of the project with stakeholder buy-in so that we're moving forward. We don't want to start over at the middle of the project if we decide to move to a different type of lighting. So now I'm going to run through some examples. We modeled an indoor grow in Palm Springs, California, using that weather file. And it's all flower. And we did this at a high level just to kind of show the contrast between some of these design choices. So the topics we're going to cover: utilities, on-site energy generation, lighting, HVAC. So first step, know your utilities. Indoor cultivation is extremely energy intensive. So you need to understand your utilities constraints and capacity requirements or limitations, rate schedule, demand costs, so forth. Here is an example rate schedule that would be applied to this Palm Springs grow. This is from Southern California Edison. And they do a time of use and seasonal rate structure. So we got summer and winter. It's broken down into summer and winter months. Summer is June 1st through September. And we've got this on peak from 4 p.m. to 9 p.m. And in the summer, that's 36 cents a kilowatt hour. That is huge in terms of energy cost. And then even the winter, you're at 12 cents, which is also very high. So the first thing I would do looking at this is I want to avoid this time, and I want to try to get into this time if I can, if you have the flexibility. Flexibility with your grow schedules, and that's what I'm going to jump into here. So we took our design and we plotted our total loads. So the blue line is our total load profile, and then we applied our utility costs. And this is basically HVAC costs and lighting costs. And you'll see in this red area is that 4 to 9 p.m. And that makes up 61% of the daily cost. Daily cost estimated at $1,100, or yeah, $1,100. And that's a huge 61% for that 1 5-hour period of the day. If we take that same indoor grow with the same load profile and we adjust that grow schedule from 10 p.m. to 10 a.m. to stay out of that peak demand area, we can drop that percentage to 18%, and now our costs have dropped down to $700 a day. So pretty huge impact, and this is not taking advantage or taking into account the advantages of in Palm Springs, the nighttime temperatures are going to be a little bit more favorable to cannabis. It's very hot during the day. Next, we'll talk about renewables and on-site generation. Cogeneration. Examples of cogeneration would be CHP, combined heat power, or CCHP, combined chilled water, hot water, and power. This is getting very popular, and definitely good reasons to consider it for cannabis because of the high power demand that cannabis has, and if you're doing a hydronic system, you're going to need a lot of hot water for reheat, for heat, dehumidification. So you've got a fairly constant supply of that, and then it also adds some resiliency to your facility, because you can couple this with the utility source, and now you've got almost a guarantee that you're not going to lose power. Just be careful if you're going to do that. You've got to have a redundant source for your hot water supply system. If you switch over to utility power, you're going to lose that heating from your cogen system. I did a real simple exercise here. We just took that same load profile, again, that blue line. We created all of our electricity from micro turbines, natural gas micro turbines, and then we plotted the cost on that same summer day, and we're down to $1,000. So we saved about $100 on that day, and that's calculated by, in this particular location, 5 cents a kilowatt hour for natural gas, and then just a price we've got from a micro turbine supplier, 7.5 cents a kilowatt hour to lease it. So these two numbers are going to be different for wherever you're at. So the important thing to take away from this is that cost profile follows the load profile, meaning that if you can do anything to reduce your kilowatt, your load, it's going to have a direct impact on utility cost. Whereas with the SCE rate, if you're still getting hammered in that 4 p.m. to 9 p.m., you got to think about peak shaving. You don't have to think about it in this because you're controlling you've got a constant rate. We did extrapolate this example out over a full year, and it was about 30 to 50% higher on utility costs. So in our particular case, on this particular building, would not be a good choice unless we could justify it with the added resiliency of having constant power that we're creating, and the hot water that is not factored into those calculations. Next, we'll talk about photovoltaics, PV, solar panels. Very flexible where these things can go. Roof mounted, if you're doing an indoor grow like this is our example is, you can put them on the roof. Obviously, that's not as viable of an option if you're doing a hybrid grow or a greenhouse. Always consider when you're doing renewables, consider that first cost. Look for the incentives in your area to really make the payback the best you can. And so we took that grow that we're modeling. Here's the load profile again. But then we put solar on the roof just to show the impact. On our particular case, it's not that great. We are saving $200 a day on a summer day, and we're dropping that on peak from 64 to 62%. But I think there's a misconception oftentimes that, oh, we'll just put solar on this to take care of our power demand and bring down our utility bill. Well, cannabis is very dense in terms of energy needs. So you're going to need a lot of solar if you're really going to offset that utility cost and those in peak shave. Unless, of course, you consider energy storage. Energy storage is going to allow us to we're going to save up that energy, and we're going to discharge it only during the peak times to really bring down those big time of use costs. Again, consider first cost, because battery storage is pretty expensive. It's going down, but it is still very expensive. And then also consider your space constraints. So lithium is going to have a lot denser energy storage, meaning it's going to have a smaller footprint versus flow batteries. Just make sure you're accounting for that as you're looking through choices, and do that early in the process. Here's that same amount of solar, same load profile, but we did battery storage and we discharged that in that peak time. We went 4 p.m. to 8 p.m. Because it matched up well with the amount of solar we had. And now we've cut that from 64% to 27%. And we've got $500 a day in savings in this in that solar system. So that's pretty significant. A very significant way to do that peak shaving. Now, obviously, this brings up another point of why the Charette process is so important. You wouldn't want to be doing this energy storage and offsetting your schedule in most cases. So it's important that you're making decisions that complement each other. Those would not complement each other. Next, we'll talk about high pressure sodium versus LED. I'm going to go through the pros and cons real quick, because I'm sure most of you already know them. High pressure sodium, far less expensive, but you're going to have limitations on how you can control it. And if you're doing a hybrid grow or in a greenhouse, you likely want to modulate that light output to get the specific power range you're looking for. With LED, far more expensive, but you're going to have a lot more flexibility to do that. A lot more control in general. So you can control the light output, you can control the light color, and you can control how you're going to deal with that heat a lot better with LED than you can HPS. And here's just a quick example. Of all the energy coming into this thing, 34% of that is coming out as light in HPS, 55% is radiated heat. Radiated heat is very hard to control when it's heat that you don't want. Very hard for the HVAC system to take care of that. Whereas LED, we're bringing on 100% power in, 40% of that's coming out as light, and 26% is convection heat. That's a lot easier to control with water cooling or remote drivers. Just a lot more flexibility on the HVAC system side. Yearly cost, I'm going to kind of flip through these pretty quick because I see we kind of lost a little bit of time there. So no surprise, here's our LED costs. It's going to peak in the summer. HPS is a little bit higher. But also, if you are in a hot climate, HPS, you're going to have to add supplemental cooling or additional cooling for your HPS system. So you need to include those costs and capacity in your design. Then we did a quick payback in our particular scenario. If you need that heat and you don't need extra cooling because of that heat, then your payback's like 10 years. And keep in mind, in 10 years, you're going to have to most likely replace all of your HPS lights at least once. So that's going to push that payback out a little further. If you do need supplemental cooling, then your payback drops in about 4 years. Hopefully that makes sense. I'm going through this pretty quick. I'm happy to jump back to that if you guys want. Next, cooling system selection. This could be a 5-hour topic all by itself. I'm going to jump through it pretty quick. Systems you'll likely see in cannabis, split systems, and when I say split systems, I don't mean like mini splits you see in a small IT closet. There's many different types of mini or split systems out there. Heat pumps, fan coils, air handlers, chilled water systems, there's many different types. There's many manufacturers in this industry that make equipment specific to cannabis. Because of most of your traditional equipment you get for an office, for example, it's going to have a higher sensible heat ratio, or it's tuned to a higher sensible heat ratio, whereas cannabis has a very low ratio. So you really need to keep that in mind. Otherwise, you're going to end up with a lot of supplemental dehumidification, which frankly I've seen seems to be very common. But that supplemental dehumidification is going to add to your power demand, and it's going to add capacity to your cooling system. And then as you're looking at these different systems, be sure you're looking at the options that are available to the system. So you may like heat pumps, but then in the heat pumps, you're not going to get, you may not get as the advantage of free cooling that you might get if you were doing air handlers, air side free cooling. So just keep that in mind. So we ran two parallel designs, one with air cooled and water cooled, to kind of show the difference in the systems. No surprise to anyone that's a mechanical designer, I'm sure. Air cooled system cost was quite a bit lower than water cooled system costs, but the energy costs quite a bit higher. We come up with a 1.8 year payback to go water cooled. I don't know how many times I've been involved in a project. I've been in a few in the cannabis arena where we're involved at the 30%. They've already laid out the floor plan. They've already laid out the site, and no one put any consideration into where the mechanical equipment's going to go. These are very, I know I've said this quite a few times, but these things are very energy intensive, meaning they're going to need a lot of cooling. And if you don't know what system you're going to do when you're laying out the floor plan, you're most likely going to get it wrong. In this particular case, the water-cooled system is going to require a mechanical room size that's 2 to 3 times the size of an air-cooled system. I've been on projects where they didn't have any room for the outdoor equipment. And I had to go on the roof, which the structural engineer did not plan on designing. So huge cost increase, huge disruption to the entire design process. So just that can be avoided with this early brainstorming charrette process we're talking about. And then very quickly, I want to talk about VPD, vapor pressure deficit. It's very important to your HVAC system. As many of you probably already know, plants pull up their nutrients through the grow medium with water, and then they want to expel that water out their stomata. If your VPD is too high, your plant's the transpiration is going to be hindered. If it's too low, the plant doesn't want to dehydrate, so it's going to close. So you're going to stunt the growth and your yield. Another important thing to note, as you raise, let's say we fix our VPD around 1.4. I've heard some growers say as low as 0.8 VPD. I've heard some say as high as 1.5. We're going to pick 1.4 in this scenario. And if you were able to accept 800 or 82 degrees Fahrenheit in that grow area, you're going to be roughly 55% lower than a grow room that's wanting 70 degrees. So that is a huge impact on your first cost. It's a huge impact on your yearly cost, the amount of space you need. I mean, there's very big impacts with just a minor adjustment in the acceptable range of indoor grow, or your indoor environment. I want to leave some time for questions, so I'm going to run through these last ones fairly quickly. We compared some systems. So we compared air-cooled with HPS versus water-cooled with LED. No big surprise, HPS and air-cooled is higher. That first cost is enormous increase with the water-cooled and LED, mostly because of the LED lights, and that came up with about a 4.5 year payback. We then took air-cooled HPS versus water-cooled HPS, and now our payback's knocked down to 1.5 years. So very important to make these decisions up front. You can save a lot of time, a lot of money throughout the design process, and also over the lifetime of your indoor grow. And then the last one, just for fun, we did a water cooled option with HPS. We put PV on the roof, and then we offset that grow schedule from 2 a.m. to 2 p.m. to take advantage of, to stay out of that super peak, high peak, 36 cents a kilowatt hour, and to stay in that super off peak where it's only 5 cents. So that yielded about 30% savings, which is remarkable. And I know all this is pretty high level, so keep that in mind. Don't focus too much on the exact numbers, because this is a high level analysis. If this was an actual design project, this would be step one, and we keep diving deeper into it, getting more accurate numbers as our energy model is developed. We dive deeper into the analysis of economizers, water side, air side. So these numbers would change quite a bit, but the order of magnitude is what we really want to focus on. And hopefully this gives you a good example of why the charrette process is so important, and why it's so important to do it at the beginning of a project. All of these decisions we've talked about are going to get made at some point in time. If they're forced to be made during construction or after construction out of necessity, then you're significantly limiting your options and your efficacy. The solutions you are going to come up with are going to have a far greater cost than if you just planned on it to begin with. I go back to that quote. It was on Anthony's slide. I love it. Easier to set a course than to change it. It's so true in the design process, especially when related to cannabis. We've left some time for questions there. Yeah, so we'll open up for questions.
Hey, Jeremy, we do have a couple of questions.
Yeah, great.
That came in, just so we'll hit these first. And I don't know if you've seen them, but
yeah.
The first one would be, would geothermal heating / cooling be beneficial in indoor cultivation?
Yeah, absolutely. If you've got, it's very dependent on your site. So, what are you drilling down to? How far do you have to drill to get the best energy transfer? But there are some great options for heat pumps in the cannabis, specific to cannabis grows. And that heat pump could be coupled with geothermal, and that would be a fantastic solution. Do keep in mind your density, again, the density of your power in a cannabis grow is pretty immense. So in a 10,000 square foot space, you might need 250, 300 tons of cooling. It could be going a little high there, which also means my rule of thumb with geothermal is always you can count on a ton and a half at most per well. So in that scenario, if you need 300 tons of cooling, you're going to need most likely 300 wells spaced 8 to 15 feet apart. That's a lot of ground to make up. So
it always seems to come down to, especially in indoor grows, it comes down to power density.
Yes, yeah. But if you've got, if for whatever reason you're in a huge area that you can expand out, and you can put these wells in, put them in, put wind and solar over top of them. Great solution if you've got the room.
Yeah, it's the same. It's the exact same way with solar. Solar is I want to put as much solar out there as I can, but the density of solar just never matches the load profile of a typical indoor grow. The ones we're looking at, 100,000, 200,000 square feet. There's no chance that solar, unless you have an immense area to cover, will ever touch that load. Yeah. And
the most likely that's going to be the same with geothermal. You're probably not going to have, on a big facility like that, you're just not going to have the resource or the ground to do that. And then you got to keep in mind, you're going to have to do that up front. That's going to be like day one stuff. You got to get those wells in before you start the process. So that's a lot of upfront capital you're going to have on a large facility.
Absolutely. Totally agree. We have time. So there's a couple more that you probably didn't see, but one was talking about fuel cells along with storage. Mm-hmm. And let's see, fuel cells along with storage, and basically only use grid when needed. I can talk a bit about fuel cells, and I've had some experience there. There's a big upfront cost that you really have to consider. There are limited manufacturers that you can tap. I mean, there's only really two that I would even think about for this scale of energy use. There's, in my mind, there's some shortcomings. Cost, warranties, but fuel cells as an idea, I've always thought of as being something really useful, and I've tried to employ it as much as possible. But I have to say, I haven't been successful in the cannabis arena with fuel cells just yet. And again, and I think the question also implies getting off the grid completely. It's possible, and we certainly look at that with CHP. It's not always necessary, and not always necessarily a good thing. You might want to stay attached to the utility at some level.
And if you're, to tag along it, if your utility rate structure is flat, and you don't have those peaks, you probably don't have a whole lot of reason to do energy storage, because you're probably going to use most of it during the process, because it's a very intense process. Unless you have some scenario where you're able to produce a lot of renewable energy when lights are off, and then you store that energy up, then it would make some sense. But in most scenarios, I would try to focus more on giving your renewables less on storage, unless you've got that big 35-cent kilowatt hour charge for a long period of time.
Right.
For example.
Yeah, exactly. Knowing your utility rate and knowing your utility is really a good idea, but knowing what rate you should be on. And if you can move from a TOU that you're discussing with a high demand and move into maybe an ag rate, right? Where there's a lot of different ways to look at these rates, and you got to find the right one that works for you. You can change, you have to talk to your rep. Don't just accept whatever they give you, right? So it's really useful to know which rate you're on. Here's an interesting one. I don't really know much about this, but someone had posed a question about using hempcrete in your build, right? So this would assume it's a new building from ground up. I do know something about hempcrete. I think it's awesome, and I'd love to explore it further, but I've never personally seen it used myself.
I heard about a recent one, but I try to stay in my lane.
Right.
On the structural side,
Right. But I think it's a great idea, and I'd love to explore it. I'd love to use it in a building, but as of right now, it hasn't happened for me. So let's see. We've got another. Well, actually, this is somewhat of an easier one. The solar tube. Someone's asking about solar tube in terms of daylighting and passive daylighting. Solar tubes. Are you familiar with those? They're mostly it's really a residential thing, but they do have a commercial offering as well. So I am, of course, all for anything passive. Passive solar is fantastic for lighting, for heating, whatever you can use it for, and the costs are pretty cheap.
I would say you've got to. So I've seen some more of a commercial or more larger scale version of a solar tube, and they're it's called Steerlight. It's basically a big skylight that has a tracking system in it that tracks the sun and has mirrors that bring that light straight out into space. And I'd be interested to see how well that performs, because you really need to be able to control your light. You need a constant amount of light, because what happens if you're using that system? You're not getting enough light that day, so you're going to bring on your other lights on the full on, or turn on some more lights. If you're doing HPS, you're going to have more limitations on that ability. If you're doing LED, you can, but you're probably buying more lights than you need to try to offset those days you're not getting enough sun. So I think it's a good idea. It should be well vetted before you go and buy it, though.
Yeah, I'm actually familiar with the one you were talking about, and it does have some mechanical parts to it too, so I'd be a little concerned about that. But solar tubes in general, great idea. But again, you're talking about redundancy. If there's not enough light on that particular day, you're gonna have to kick everything on. So redundancy is the big buzzword for us. I think both of us really think that's a very important word.
Yeah, especially in cannabis. The plants can't go home. They gotta live in that space somehow.
Yeah, they're not going home. Yes.
Very robust, but the price of cannabis is dropping so much. You really got to be a player in the market. You've got to have good yields. So if you're doing stuff that affects your yield, you may not kill the plant, but if your yield's not as good as the next guy, their problems staying alive.
Exactly.
I'm getting different questions pop up in my end.
Go ahead. Go for it.
Benchmarking tools, have I used any to track energy, water, and waste? I have not personally. Usually once I'm done with a project, it's handed over to the grower. And I know there's a lot of tools on the grower's side to track that and to control them, interact with it. So they're closing blinds, they're adjusting the cooling system based on the time of day and how much light's getting and how much heat is above blackout shades or shade systems. So there are definitely neat tools out there. I've not used them personally, so can't speak to that.
Yeah, I'm also aware of those tools, but yeah, on the backside, we don't do much of that tracking, which we should. But it's really out of our hands at that point. It's really more on the grower side, and it's a great question because I don't know how many growers actually benchmark or actually keep track of all these things that we help them employ, and do they, we really need to track those for our use later on. How well did it do, and that's really on them at this point. I think there's one on there that I see that might be interesting. It's what are the minimum power density and energy consumption, kW per square foot and kWh per square foot per year you have seen in indoor grow? So what's the general profile that you've seen, if you can?
I don't know off the top of my head, or I don't want to say off the top of my head, rather. Yeah. I've got kind of my own cheat sheet that I start on a project, because a lot of times we'll go into a project and you're not getting that engagement from the growers, the owner, or whatnot, but they still want you to force forward. So you got to use numbers like that. And I don't like to do it. I would not, I wouldn't advise doing it. I would advise getting that information. If you saw by those charts, you could end up with way overdone design system, or worse, even worse yet, a very undersized system where you don't have enough power to run the facility or enough cooling to keep it up and going. So, sorry.
No, that's good.
I'm sure I'm happy to talk to you about more experiences. I wouldn't want to give you a minimum number because it depends on what stage of growth the plants are. Or do you have a growth facility that's early stage and then you're cycling it to another area for late stage, or do you have all late stage? Do you have mother? Do you have veg in the room? So it really changes depending on what you're doing. So I wouldn't.
Yes, agree with you. I'm with you 100%. We go through that all the time, and there's sort of this educated guess that goes out, especially in new construction. Obviously, there's no data, there's no baseline in which to tack it to. So it is sort of an educated guess, and we have to look back at other operations potentially, and where is it located? What where's this grow? Is it in
absolutely
strengths?
Yeah. Good point. That's going to have an extreme effect on your watts per square foot.
Yeah, it's heating or cooling, but I'm down. What me and you right now are dealing with mostly is desert operations. So we're looking at cooling and lighting loads, right? In Colorado or up north in Oregon, et cetera, there's greenhouses, of course, everything's different. So we have to they're all one-offs, I guess, is the answer to that, right?
Good. That's a great point.
Yeah. Let's see. Oh, wait, I did see another one. That's actually the last one I see here, unless you have a.
I just got one coming from Marcus. Considerations for using solar panels for cultivation.
Yeah.
So I would say, if let's say, for example, you've got a lot of flat roof, I'd say fill it with solar panel. With the cost of solar and some of the incentives that may be available to you, I think it's going to pay back. It is not going to, if it's just going on the roof of your grow, it's not going to make a significant dent in your daily cost, but it's going to pay for itself. Would you agree with that, Anthony?
I would agree that it is going to pay for itself. Yeah. Well, again, depending on your rate schedule.
Yeah.
So, I mean, and it doesn't do a darn thing for demand. So forget demand. Demand is either going to be storage or combined heat and power, something else that we can offer. But solar is going to be is not very dense. You really need a lot of space to accomplish a lot. Federal incentives are going down. Right now it's at 26%. The federal ITC is 26%. It's going to start to march down as well. So the sooner the better, I would say. There's a lot of tax implications with solar, and if you can utilize those, go for it, own the system. If not, there are third-party offerings, leasing, et cetera, but solar's great. I love it. I put it on everywhere I can and push it. But again, they're all one-offs, and we have to look at this thing legitimately, and we can't just push an idea because we think it's great. And that kind of goes back to the whole idea of what we're talking about here. And all of these design issues need to be considered and really understood before we move forward.
Another question: how's that different in a climate like Hawaii? Man, I want to be hired for a project in Hawaii. And when that happens, I'll let you know, because I've never done a project down here. I don't really know the conditions.
Hey guys, we're gonna have to. This is a great discussion, but we're gonna have to wrap it up. Sorry.
No problem at all.
Great combo though.
Thank you so much.